we're going to start with radical expression vocabulary. Now, this stuff, we've done radicals before. We just did square roots, right? So, hold on, let me get to my radical expression vocabulary page. So we need to define what all these things are because we're going to be using them kind of more specifically. So we're going to kind of take what we did before and we're going to expand on it. Okay, so first of all, this thing right here is called the radical sign. Let me actually write in pen. Radical sign. Some of y'all call it the check mark division sign. That's not what it is. It's a radical sign, okay? So the radical sign is used to find roots, square roots, cube roots, 4 roots. I know they have a name other than 4 root, but that's what I call them. Once they get past 3, it's a 4 root, a 5 root, a 20 root, whatever it is, okay? So when I look at that, these are all different types of roots. So this, every time we look at a radical sign, it has an invisible 2 exponent. This is great. Sorry, internet, I can't find my pen. Okay, so if you don't see a root, the invisible root is 2. So normally, you know how we have all the invisible 1s around a number? So we've got the 1x to the first power over 1. Normally, the invisible is a 1. But on a root, on a radical, it's a 2. The invisible is a 2. So if you don't see, and that's the reason why everything we've done up to now, we've found square roots. Because the square root is a 2 root. Because we have the invisible 2. We've never had to worry about it because we've never done anything else with radicals. Okay? So, now, some of these, you notice some of these have a number there. Instead of being a 2, there's a number there. So this one has a 6, a 5, a 3. We call that number there, we call it the index or root. Okay? We call it the index or the root. So I think of it as an exchange rate. Okay? How many of y'all have been to another country? I have been to one other country. My mom took us on a cruise. She was very excited. She's never been able to take us on vacation. She finally took us on this cruise because she came into some money. So when we went on this cruise, when we disembarked, we had to actually exchange money. And my American dollars weren't equivalent to the other one, so I had to exchange them, okay? Similarly, if I go to, let's pretend, because we had that pack lesson today, let's pretend I go to the pack store, the school store, and I decide I'm going to change some of the pack bucks into an eraser. Let's pretend that an eraser costs 10 pack bucks. So I take my 10 pack bucks and I exchange them for an eraser, okay? That's what I'm talking about when I think of an exchange rate. But what this exchange rate tells me is how many of the same number I have to have. So, let's say so this is a 2. I have to have 2 of the same number. I can exchange 2 inside for 1 on the outside. This is a 3 root, so I have to exchange 3 of the same number for 1 on the outside. For this, 6 of the same number for 1 on the outside, 5 of the same number for 1 on the outside. Okay? So let me really quick take a detour and let me show you how that works. Okay, so let's look at the 6. Okay? We're going to talk about the principal square root. I know we've talked about having a positive and a negative root, but we're going to talk about the principal square root today because I don't want to deal with the negative. Okay, for now we're just looking at the principal. Okay, so what is the square root of 36? What is it? 6. It's 6, right? Okay, y'all know that. You can put it in your calculator and find it. So let's talk about this in terms of how we're simplifying. Okay, well, if I think about the square root of 36, it has an invisible 2 root on it. All right? If I were to prime factor that root, do prime factors of this number, which, by the way, let's scoot up here real quick. This number under here is called the radicand. I know, it all sounds like Pokemon now. I choose you, radicand now. So we have the radicand and we have the radic. What's next? I don't know. So the radicand, okay, if I find the prime factors of the radicand, it's 2 times 2 times 3 times 3, right? Do you guys agree with that? Because, I mean, if we put that in my calculator, if I turn it on first, 2 times 2 times 3 times 3 is 36. And those are all prime numbers, okay? Now, my invisible 2 says that if I want to pull something out from under the radical sign, I can exchange a pair for one on the outside. So I have a pair of 2's and I have a pair of 3's, right? So that would be, on the outside, I'd have a 2 and a 3, and then there's nothing left under the radical. What's 2 times 3? 6. The square root of 0 is nothing. In simplifying square roots behavior, that's the math that happened to give you the square root of 36. Okay? So, let's talk one last thing, and then I'm going to have you guys try an example. Okay? So this one, it's the n root of x to the m, or the n root of x to... All this means is if you see an exponent, it's still an exponent or a power. Okay, that doesn't even look like a word. Or a power. Okay, so it's still an exponent or a power. Okay, I want you guys to try to do the same thing that I just did here with 100. So I want you to take this. Okay, the square root of 100, it's 10. We know this. But I want you to go through this process where you prime factor, take pairs, and pull them out from under the radical. All right, so what we should be doing is you should be taking the square root of 100, right? Well, if I take the prime factorization of 100, it's 2 times 2 times 5 times 5, okay? My invisible root is 2, so that means I have to pull these out in pairs, okay? It should go away. We have a pair of 2's and a pair of 5's. Okay, so I can take out a pair of 2's. I can exchange that pair of 2's for 1, 2. Exchange that 5 for a 5. And there's nothing left under my radical. So basically, my radical disappears. Well, 2 times 5 is 10, which is what I expected my square root of 100 to be. Okay? Now, that was easy. We know what to do with those, right? Now, what about something like the square root of 27? If I put the square root of 27 in my calculator, I get that garbage. Okay? I don't like that. Okay? And furthermore, that's not what we're looking to do. We are simplifying. Okay? So when I simplify something, I'm not trying to find an approximation, which is what this is. This is solving with the calculator. I'm not trying to find an approximation. I'm trying to find a simplified version. So, let's look at this one. Okay, so for this one, I'm going to start by doing prime factorization of 27. Okay, so if I take I'm just going to take it up here just so I have a little room to work. Okay, 27 is 3 times 9. And 3 is prime, so I'm going to circle. All right. 9 is 3 times 3. And 3 is prime, so I'm going to circle it twice again. I got nothing left, so I have prime factored this thing, okay? So the square root of 27 is equivalent to the square root of 3 times 3 times 3. Do you guys buy that? You with me on that? Okay, great. I'm glad. Now, what is my invisible index? Always. It's 2. So that means I have to take these out from under in pairs. So there's one pair. Change that pair for 3 on the outside. What's left under the radical? So the answer is 3 square root of 3, because I can't take that 3. I can't take that other 3 out because doesn't have a buddy. Now if I put 3 square root of 3 in the calculator, I get the same garbage, which means they're equivalent. Okay? So when we talk about simplifying radicals, that is what we want to do. Okay? I want you guys to take a moment and I want you to try the same thing with the square root of 20. I want you to try the same process up here with the square root of 20. So, for this one, when we do our prime factorization, y'all should have gotten 2 times 2 times 5. And this is a 2 root. So I'm going to take them out in 2 at a time. That means I have a 2 on the outside and a square root of 5 on the inside. Okay? Now, this one's a little bit more complicated. Okay, so let's try 30 square root of 32. We're not going to do all of these, okay? But let's try the square root of 32 here, okay? So I'm going to go up here, I'm going to do some prime factorization on 32. Okay? 32 is, what is it, 8 times 4? Yeah? Okay. Well, 8 is 2 times 4. 2 is prime, so yay, I got something prime. 4 is 2 times 2. Those are prime. And this 4 is also 2 times 2. Okay? So how many 2's do I have? 5. 2 times 2 times 2 times 2 times 2. Okay? So, I can group those up. Again, since it's just a square root, I can group them up in pairs. And this time I can take 2 of them out. So I have 2 on the outside and another 2 on the outside. And then I have 1, 2 on the inside. Those 2 that I pulled outside, everything I pull out and everything I leave in, I multiply back together. So 2 times 2 is 4 square root of 2. And we can confirm that that's right by taking the square root of 32, which is that garbage, and 4 square root of 2, which is the same garbage. Yes?
Instead of 4, I did 2 squared and I got the same answer.
Yes. So you did 2 squared, square root of 2? Mm-hmm. Okay. And that is fine. But 4 square root of 2 is a more simplified answer. But they're equivalent. So if you put 2 squared, square root of 2, those things are equivalent. But this is the answer that they're looking for. So you're not wrong, but they're looking for the 4. So that's good. I like it. All right, so let's talk really quickly about this guy right here. Are any of you starting to see that there might be a different answer if we prime factor, that maybe undefined isn't the only answer we could put? So let's think about square root of negative 25. How can I find negative 25? 5, which is prime, times negative 5, which is not prime. Because it's negative 1 times 5. So, technically, we could say that this is the square root of negative 1 times 5 times 5. And I could take out this pair of 5s and have 5 square root of negative 1. Okay, I can totally do that. But we're not going to. Yeah, no, it's okay. I want you to know, if any of you are starting to see that kind of stuff, you're starting to think, hey, what about the square root of negative 1? Couldn't we just leave that under there? Or thinking, maybe some of you all have already heard about I. Okay, what I want you to do is what we've been doing, which is undefined. In Algebra 1, we're going to call that undefined. But if you can see that this is true, I'm glad. That means you're a little bit ahead. Okay, you're a little bit ahead because we're not worrying about this. This is like an Algebra 2 thing to worry about. We don't worry about I right now. We're not worrying about imaginary numbers. This is the imaginary number, square root of negative 1. Okay, but we're not worrying about that right now. We're going to keep it undefined because undefined is one of our big skills. It's undefined slope. It's undefined solutions, okay? So we want to make sure that we keep ourselves thinking about undefined. Make sense? Okay, so let's talk about one other thing. So I'm going to use the square root of 1. Well, okay, so the square root, so you know that 1 times 1 is 1, right? So I can take the square root of 1, I can take any root of 1 and get 1, okay? So what about the square root of negative 1? It's error, non-real answer. Now, let's try something else. What about the 3 root of negative 1? It's not an error. let's talk about it first, and then I'll show you how to do it on the calculator. I want to talk about this, and then I'm going to show you how to do that what I did on the calculator. Okay, so here's the 4 root of -1, and look at it. It's an error. Here's the 5 root. Whoopsie, I forgot to hit something. The 5 root of -1 is -1. So what do you guys see? Say it again. Odd numbers. Look, this has an invisible 2 root, and it gives me an error. A 3 root works. 4 root is even, gives me an error. 5 root works. So I can take a root of a negative number when what's odd? The index. Thank you. When the index is odd. Okay? And it's not possible when the index is even. Okay? All right? So next thing y'all wanted to know was, how did I get the calculator to do that?
Yeah.
Well, I'm going to show you. I'm so glad you asked. Okay, it's tricky. Actually, I kind of messed it up the first time I did it. So here's what you have to do. And I'm going to write this down, and then we'll try it, okay? So the first thing you do is you type the index. So if it's a 2, a 3, a 5, whatever it is. Then you hit Math 5. Then you enter the radicand, my favorite Pokemon, and then you hit enter. Okay, so write that down, and then we're going to take a look. We're going to see what that looks like, and we'll try it on this first problem, 4 to the 16, the 4 root of 16. Okay. Okay. So I hit 4, and then math. And if you notice, math 5, it's like an x root. So it's like it lets me define. Now you have to hit that first because whatever number is right in front of it is what it makes your index. So now it makes it a 4 root. Whatever the radicand is, which is what's under the radical sign, I put that in there and I hit enter, and then it tells me what the root is. So the 4 root of 16 is 2. Second, and try these other ones, and then I'll work through them. The 3 on the bottom. So again, so I hit 5 on this one. I hit 5, and then I hit math 5, because 5 is the x root of something. I enter the radicand, negative 243, and I hit enter, and it says the solution to that is negative 3. All right? Let's get the other ones done. I already know the answers to these. Okay. When you're done, check and make sure I did these right.
Yeah, you got them right.
Excellent. I can math. This is a very big day for me. All right, so let's go to our fancy foldable and let's write some of this down. All right, let's write some of this down. So we are in this next section here. Right here. Okay. It's delightful, isn't it? It's just a pleasure. It's a joy. This is a joy. It's just a thank you so much. Oh my gosh, you guys. Okay. So I've been working through these instructions for the last 3 class periods. So we're going to write them down, and I hope that they make sense. It took us a couple periods for it to not to be. I mean, I crossed this out a lot of times. Okay. So simplifying radicals. And simplifying radicals is not on your formula chart. You just got to know how to do it. Now, obviously, on the STAR test, we're going to use our calculators, right? We're going to stick the question in, we're going to stick the answers in, and we're going to see which ones give us the same garbage, right? Okay. Huh? Yeah, if it says y equals, I'm going to be like, ah, my finger's going to go right to the y equals button. I'm not going to be able to stop myself, okay? Okay, step 1. Expand to prime factor. which doesn't even make sense. Oh, to prime factors. So expand to prime factors. That looks like a Y, but it's an R. Okay, expand to prime factors. So we're going to start by expanding, prime factoring so that we can expand it. The second thing we're going to do, and this is a weird instruction, but listen to it. We're going to circle groups of the index number. So like if our index is 2, we're going to circle groups of 2. If our index is 5, we're going to circle groups of 5. Okay, so circle groups of index number. Okay, and that's just a really hard thing to verbalize. Okay, and I'm gonna do an example. Okay, now we're gonna exchange one group under the radical sign, and I just drew the radical sign. I don't need to be writing radical sign, for one outside. So we're going to exchange one group under the radical for one of them outside, for one outside. Okay. We're going to multiply outside, multiply inside. Okay. So we're going to expand to prime factors. Circle groups of the index number. So whatever that index number is, we're going to circle groups that have that many in them. We're going to exchange one group under the radical for one of that thing outside. We're going to multiply our outside and multiply our inside. Multiply outside, multiply inside. Okay? So let's try an example. First example. The square root of 150. Now look, I'm just going to give y'all the prime factors because we don't have time to be prime factor in this, okay? So the square root of 150 is equal to the square root of 2 times 5, okay? Whenever you're doing this, I want you to always write the invisible root so you know what you're grouping it in, okay? So I expanded to prime factor. That was step 1. Now I need to circle groups of the index number. Well, 2 doesn't have a partner, 3 doesn't have a partner, but 5 is part of a pair, so I can circle those 2 5s. If the index was 3, would I be able to circle anything? No, because I don't have 3 of anything, so I would just be done. The 3 root of 150 is the 3 root of 150, because I can't make that any more simple, okay? So I can take that 5, I can exchange those 2 5s for 1 on the outside, which gives me 5, the square root of 2 times 3. Because now I have a 5 on the outside and 2 times 3 on the inside. And then I simplify by multiplying whatever's on the outside and multiplying on the inside. I've only got the 5 on the outside. On the inside, I've got a 6. I can confirm that that's right by sticking them both in the calculator. Okay? So the square root of 150 is that garbage. And 5 square root of 6 is the same garbage. Yay, I did it right. Okay? Here's a second example. And I am most definitely going to give you the prime factorization of this one. Example 2. Square root of 864. I bet you do. I bet you already know what that is. Okay. Square root of 864, the prime factorization, and again, I mean, I don't think you'll see anything this tough, is 2 times 2 times 2 times 2 times 2, that's 5 2's, times 3 times 3 times 3. So 5 2's, 3 3's. Okay? What's my invisible index? 2. So that means I'm taking these out in pairs. So I can circle the first 2. And the next, so the first pair of 2's, the second pair of 2's, but can I do anything with that last 2 there? No, it doesn't have a buddy. Okay, what about these 3's? I can circle this first pair of 3's, but that last one doesn't have a buddy. Okay, so now I'm going to move these, I'm going to exchange these, okay, for one on the outside. So I can put 1 2 outside, another 2, and a 3. and I'm leaving a 2 times 3 on the inside. Okay? So you see how I'm multiplying everything. So now all the factors I pulled out from under the radical, I multiply together. All the factors I left under the radical, I multiply together. And that gives me 12 square root of 6. Okay? All right.